One of the jobs that chemists do is to make new chemicals. It used to be the only way of confirming the structure of a compound, but now new chemicals are made in the hope they will be useful in everyday life, for example as medicines. For every medicine that becomes commercially available, many thousands of new compounds are made and tested. How do chemists work out how to make new chemicals? To understand this, we need to recall the reactions of the organic molecules. Recall the reagents and conditions required for these reactions. When planning how to synthesize an organic molecule, we usually refer to the material that we are trying to make as the target molecule. The material that we are using to make the target molecule is called the starting material. It may take several steps and a number of intermediates to get from the starting material to the target molecule. This is called the synthetic route. One way of working out which route to take is to write down the displayed formula of the starting material and the target molecule. Then write down all the compounds that can be made from the starting material and all the ways you can think of preparing the target molecule. You should start to be able to see a route to convert the starting material into the target molecule. Let's try this with a real example. How could we make 2-bromopropane from propan-1-ol? There is no direct way to convert propan-1-ol to 2-bromopropane, but you can convert propan-1-ol into an alkene and then make the halogenoalkane from that. Step 1 is to dehydrate the alcohol to produce the alkene, propene. This is done by passing the propan-1-ol vapor over heated aluminium oxide. Step 2 is converting propene to 2-bromopropane. This is easily done by adding hydrogen bromide across the alkene double bond to form 2-bromopropane. This reaction occurs at room temperature. What happens if there is a choice of routes? How do chemists choose which one to use? The key factor in deciding is the yield of the product. In industry, chemists aim to get the maximum yield of product as cheaply as possible. This means they will choose a synthetic route with as few steps as possible and one that uses the least expensive starting materials.